In this video and the next, we're going to focus on the slides from this PowerPoint right here, strings and text file I/O. And this is the PowerPoint. So there's really two main topics here, corresponding with two chapters from the textbook. Chapter 4 deals with a lot of things, including strings, other things as well. They cover some of the specifics of the math class, for example. And chapter 12 has to do with text file I/O, and amongst that stuff, you'll start getting into some dealing with exception handling. For this particular video, we'll focus on strings, and then in the next video, we'll focus on the text file I/O. And so it's important to understand the string class. It's part of this java.lang package. And you worked with the system class, you've worked a little bit with the math class, you have certainly worked with strings, you've created strings and used strings, and of course you worked with the system class. Remember system.out.println, system.in, which is the input stream, system.out is the output stream. So all of these are kind of embedded and included in whatever Java program you have. You don't have to explicitly import the java.lang package. One thing to note is that you can never change the value of a string once it's been created. The term for this is immutable. There are string-like objects that you can change, but strings aren't amongst them. What you can do with strings is you can combine them together to make other strings. You can extract out parts of the string like a substring and generate another string based on that substring. You can create another string by converting the letters to capital or lowercase. So there's a lot of things that you can do to combine strings or take pieces of strings to make new strings, but you cannot change the contents of a string, unlike many other kinds of objects where you can change them. So when we're coding, we'll probably typically be writing a line like this. So here we're going to create a variable of type string. We're declaring the variable of type string. The variable is called s, and then we just assign some literal string value to it. If it's a literal string value, that value doesn't reside in the stack. It doesn't reside in the heap. It resides in a whole separate location in memory called the constants pool. So this is kind of how we probably are doing this mostly when we're initializing a string. Another thing you could do is actually use the new keyword and instantiate a string object. And then that string object that you've instantiated programmatically, as opposed to just by virtue of having this literal value, is going to be located in the heap. So there's two different locations in memory that we're going to be looking at here. We've got the heap and we've got the constants pool. And recall that unless we have primitive data, which means the 4 different kinds of integers, or the Boolean, lowercase b Boolean, or the char, or the float, or the double. Other than those, everything is going to be a reference to something that's located elsewhere in memory. So where is elsewhere in memory? Well, elsewhere in memory is either the heap, or if this is something that is a literal value like we see here, or for that matter, even if it was a number, a literal numeric value like the number 10 in your code, it's going to be located in the constants pool. Another thing to think about also is that we may, even if I had this string multiple times, this literal value multiple times in my code, there's only going to be one of these in the constants pool. So whatever that string is will be referenced in the constants pool. Even if you see it repeated in the code, there's only going to be one of them in the constants pool. And we're going to see that as we execute an example that I will present to you shortly. And as we do this, we're going to have to concern ourselves with how we make comparisons between strings. And this right here would be a very tempting thing to do, just using the relational operator. But what this is really testing to see is not whether the two strings have identical content, but whether the two variables, S1 and S2, these two reference variables that are referencing a string, that are string variables, whether they are in fact pointing to the exact same object on the heap or in the constants pool. So oftentimes that's not what you're looking to do. Oftentimes what you're really looking to do is this right here, testing to see if two different strings in two different locations in memory have the same content. So, back in your Python coding, you could get away with something like this. But when we're dealing with Java, you're safer to do this right here. And we're going to see that also as we go through this sample code that I'm going to show you. There's lots and lots of methods of the string class. A string is a complex object. It has different pieces to it, and it has a lot of behaviors. But again, the string object cannot be changed. It's immutable. You cannot make a change to an existing string object. Here's some other useful methods. I call these instance methods. And later, when we talk more about object orientation, we'll make a distinction between instance and static methods, or for that matter, instance and static variables. We'll get to that later. But instance methods really means that for any instance, it will have its own behavior for to uppercase. So if I call to uppercase, it's going to return me a string, another string that is the same as whatever the string that I was looking at, only in uppercase. And to lowercase, getting a substring. Notice where it ends. It ends at end -1. And it starts at start. And strings like arrays are zero-based indexing. So the first character is character at position 0. You can find out what is the character at a particular position. It returns a char. What's the length? All kinds of useful methods having to do with strings. So we're going to look at an example that I've provided for you. So this isn't an example from the textbook. Chapter 4 has some useful examples. Chapter 12 does too. But in this couple of lectures that I'm going to give, I'm going to be using some of my own examples here. And so we can download that example from Canvas. Let me go to Canvas to do that. So in Canvas, let me close these class notes here. And under Code Examples, you will notice that there is one called String Examples. And so this is a package, and it's going to contain a couple of classes, but one that we're going to look at in detail here. And now we have string examples, and you'll notice that there are two examples. We're going to focus on this one, string examples. There's another one called string tokenizer example. If you're interested in working with tokenizers, I'm not going to get into that in this lecture, but it might be something to play with in your own time. So now if I'm in NetBeans and I scroll down here, there's string examples, and this one right here, oops, not this one right here is the one that we're going to run. I'm just going to go ahead and run it. It's going to show you some stuff that probably you won't really understand what it's trying to tell you, but you'll notice that sometimes it's saying the string references point to the same object, and sometimes it's saying they point to difference. And sometimes it's saying the contents are equal, and sometimes it's saying they're different. And as we go through this, it's going to ask me to enter this specific text, another string, because I want to actually create another string that has that value. You'll see why as I go through the example. And when I do that, it's telling me different objects, but their contents are equal. And then it's converting to uppercase, and it's getting a substring and doing things of that nature. So let's take a look in more detail at this code and what I'm trying to illustrate with this code. This whole notion, again, of the difference between two variables referencing the same object, the same string object, versus two variables referencing string objects that have identical content. Those are two different questions, and I want to illustrate that. So if we break down this code, it's a class that has a main method, and down toward the end, we're doing calling some methods to uppercase, substring, etc. We'll get to that. But earlier on, we have two variables, S1 and S2, and we initialize them to some kind of a value, and then we ask two questions. We ask, are the references pointing at the same object, S1 equal S2, either yes or no, or the other second question is, do they contain the same content, S1 dot equals S2, yes or no? And we're going to get different answers depending on circumstances. So in this circumstance right here, we have a literal value, a string, and that's a literal, so that's going to be in the constants pool. And there's only going to be one of them in the constants pool, even though I have it twice here in my code, and we'll see that. In this case right here, we use the new keyword to instantiate strings, again with the same values to them, but when you use the new keyword, those strings, as we will see, are going to be put into the heap, not in the constants pool. And then here we're doing there's another literal value, another string that's going to be, that's also in the constants pool. There's only going to be one copy of that. By the way, there's a copy of this string and a copy of this string. And only one copy of these two strings, right? Because here, the string references point to the same object. Well, that's the exact same string down here. So there's only going to be one copy of those in the constants pool. Every single literal that you see here there's going to be one copy of that value in the constants pool. Okay, so back to here, we've actually assigned another value into S2, so obviously S1 and S2 are going to be completely different. Then we assigned S2 into S1. That means whatever the contents of S2 is going to be copied into S1. What is the contents of S2? The contents of S2 is a reference. In other words, a pointer to something in memory, either in the heap or in the constants pool. And so when you say S1 equals S2, then S1 is going to be pointing at the exact same thing that S2 is pointing at. And we'll see that as well. And then finally, we're asking the user to enter a value. And that value, I wanted it to be exactly identical to another string, which we had seen from back here. But in this case, it's being input by the user via the input stream, standard input stream, using this next line method. And then we'll also be doing both of those tests. Does S1 point to the same object as S2? That's one test. Do they contain identical content? That's the second test. So let's take a look and see what's happening in memory as this code executes. So for this first one, what happened? Well, two variables were declared, S1 and S2. Here's our two local variables in main's frame on the frame stack, sometimes called the call stack. And again, we always have args because args is, for main, we all have args because args is the parameter that's passed in. And you can see that S1 and S2 are both going to be pointing at this very same object that's in the constants pool, a string. Here's this other one, by the way, with another string. We'll see that something's going to point at that at some point. But right now, they're both pointing at the same object. That was the effect of these two lines of code. And now, what have we done? Now we have instantiated two string objects using the new keyword. When we instantiate something with the new keyword, the object gets created in the heap. So here's a string object that's in the heap. Here's another string object that's in the heap. Now, for simplicity's sake, I'm saying the value, which actually, as we will see, because I'm going to show you in the debugger, the value, which is a char array, an array of characters, is actually embedded in the object itself. When we're dealing with strings and values, I want to simplify things, because otherwise, if I was going to really be accurate about this would be pointing off to here, and this would be pointing off to here. An array, remember, when we learned about arrays, where are arrays located? Well, arrays were located in the heap. A variable that was of type array would be a reference to something that was on the heap, or sometimes could be in the constants pool. So, but for simplicity, we're just putting these values here. Point being, S1 and S2 are pointing at different objects, but their contents are identical. So S1 equals S2 would be false, but S1 dot equals S2 would be true. Now we get to a point right here where we've assigned this value right here into S2. What that really meant was that S2 is now pointing at the constants pool, because this was a literal value pointing at the constants pool that has that string object. And then, what does that mean? That means that this thing here that's in the heap, nothing's pointing at it. And when nothing is pointing at an object in the heap, then there's no way to access it anymore. So one of the things that the Java virtual machine does is memory management. And basically what the Java virtual machine periodically will do is something called garbage collection, where it looks in the heap for any unreferenced object, any object that does not have something pointing at it, and basically clears up that space. And so therefore this object will disappear, and whatever space it was taken will now be available for future use. That's what the garbage collector does. That's happening behind the scenes. We don't have to worry about that. And that would not have been true if we were coding in C or C++. If we were coding in C or C++, then we would have to explicitly delete any object before we remove the reference to it. That's one of the reasons that Java is often considered to be a simpler language than languages that preceded it. So that's what happened as a result of this statement right here. And then what happened here is that the S2, when we assigned S2 to S1, what was the contents of S2? Let me go back to here. The contents of S2 was a pointer to here. The contents of S1 was a pointer to here. And now that we have assigned S2 to S1, the contents of S1 becomes identical to the contents of S2. So both of them are pointers to this very same object. In that case, the test for equality of reference will succeed. Both they have equal contents and they're pointing at exactly the same object. And then finally, when the user had entered another string, this value another string, so they typed in the exact same thing that we see in the constants pool. But what they typed in was not a literal that was in the code. That was them typing, the user typing that in. So what happened? A brand new object, string object, by virtue of this next line method call. So what is next line returns for the scanner? Go ahead and look in the documentation. Next line returns a string. And so next line is returning a string which means that it created the string containing the value that the user had typed in. And we assign the reference to that string into S1, so now S1 is pointing here. So here once again, S1 does not equal S2, but the contents of the object pointed at by S1 is equal to the contents of the object pointed at by S2. So, lesson. This is not the way to test for equality of string contents. If you want to test for equality of value, which is usually what you're trying to do, this is the way to do it, using the equals method. So now, looking at the code, here was where we had done this, and then this if statement right here, and this if statement right here, produced these two outputs. So that was when they were both pointing at the same string in the constants pool. Then when we created instances on the heap, these were the two outputs. So they pointed to different objects, but their contents were equal. And then when we assigned this, they pointed to different objects whose contents were not equal. And then when we assigned S2 into S1, they pointed to the same object. And then when the user entered a value, and the value was another string, and you can see that I had entered that, now they're pointing to different objects, but their contents are equal. I'd like to show you that in the debugger. So I'm going to set breakpoints. I'm going to set a breakpoint right here where we're right about where we're testing for equality after we've assigned values into S1 and S2. I'll do the same thing after the second set of assignments. I'll do the same thing after this assigning a different value into S2. And I'll do the same thing after assigning S2 into S1. And then finally, I'll do the same thing after inputting from the user. So I'm going to debug it. And we stop at our first breakpoint. And once again, if I want to see what my variables contain, there's my args, there's my S1, there's my S2. We can see that S1 and S2 are both strings, but we don't really see as much detail as I'd like to see. So I think I'd like to show you some other features of the debugger. If I go to Window and I go to Debugging, well, first of all, let me show you breakpoints. If I want to see what all the breakpoints are, I can see the breakpoints. If I want to delete breakpoints, I can do that in here, just like I can do that here, just to let you know. But that's not what I really wanted to show you. What I wanted to show you was another window, useful window, called the Watches window. And in the Watches window, I can actually enter an expression of some sort if I'd like. For example, I can see S1 and S2 here in the variables, but I can also see S1 and S2 in the watches. Let me just go ahead. I'm going to type S1, and there's S1. I'm going to type S2, and there's S2. Now, let's just take a look at hovering over these expressions here. Are they equal? Yes, they are. And are their contents equal? Of course they are. But it's not really obvious to see that in here. So let's look at some pieces of S1 and S2. Let's look at, for example, the value of S1 and S2. So I'm going to enter another watch. S1.value. And what is S1's value? It's an array of characters. It's a char array. So this is something that's happening kind of under the hood. We don't really have to worry about that ourselves. But keep in mind this. Look at the #104. That's basically saying this is a location in memory. Really what it is a unique identifier of that object. Let me do S2.value. And you can see they're exactly the same. I'm going to do one other thing here, which kind of gets us a little deeper even into things. I'm going to really look under the hood here. There is a method of the system class that will help to display the unique identifiers of every object that you've got, strings or other kinds of objects. Let me do this. I'm going to, in my watch, system.identity hashcode. And I'm going to put S1 there. And here is the identity hashcode, kind of the unique identifier of this object during the execution of our program. And I'm going to do the same thing, and I'll do it for S2. And you can see they're exactly identical. Okay, let's continue. Now we're going to instantiate two new strings using the new keyword. And let's see what happens here. We're instantiating two new strings. Notice that the identity codes are different. But notice also that the values are really the same thing still. So each one of these string objects, two separate string objects. Let me show you that. Here is S1 equal S2. That's a false. Nevertheless, their contents are identical. That's a true. Two separate string values. Each one is referencing a character array. So they're two separate string objects. Each one has a member variable called value, which is a reference to the exact same character array. Isn't that something? Two different objects, but they're representing the exact same character array. Not the same object, two different objects. Let's go to the next one. And in the next one, obviously they're different. And you can see that they're different. The values are different. The character arrays that they're pointing at are different. And these are two separate different objects, which shouldn't be surprising. And then now we're going to get to this point where we're assigning S2 into S1. They're going to be exactly the same again. And you can see same values, same references. Their character arrays are pointing in the same place, and the same exact identity hashes, same exact object. And then finally, the user is going to enter in, so I go to my output and make sure I have my breakpoint here. I do. Let me go to my output, and I'm going to type another string. I'm going to hit enter, and here we are. Let's go to my watches. Two separate objects. Two separate character arrays, because this another string was entered by the user, not something that was in the constants pool, the literal, but identical values. So S1 equals S2 is false. S1 dot equals S2 is true. So again, I'll emphasize this lesson. You're testing for equality of strings. You're likely to make mistakes if you use the relational operator equal. Your best bet is to use the equals method. Or if you don't care about case sensitivity, remember there's always the equals ignore case. Or there's also the compare to, where you can say if one's greater than the other or the other's greater than the first. Look those up. And again, there are these different methods as well. So let's take a look at some of these other different methods. So here's an example of using two uppercase. It creates a brand new string. Remember, it's not changing. It's not changing the object that S1 points to. You can't change that object. Strings are immutable. It's giving me another string. And this is giving me another string, beginning at position 3, so that would be the fourth, 0, 1, 2, 3, and then actually going only up to 4 and 5. So oddly, the end value that you put is actually one less than that, that's actually returned. And the other thing is, if you don't put a value at all, then it's going to just take you beginning at your starting point all the way to the end of the string. So you don't have to have a second argument to the substring method. That makes the substring method an example of what's often called an overloaded method, and we're going to talk about method overloading when we get to methods later on. Another thing to point out is that you can actually kind of cascade string calls, or actually cascade method calls, because if one method returns an object of a particular type, then you can call methods of that particular type. So substring is returning a string, and then I can call two uppercase on whatever substring returns. So here's a string, S1, referencing a string. Substring gave me another string. So on that string, I'm calling two uppercase. And so let's look at that in the code. So I'm going to put another breakpoint right here, right where we're starting to call these other methods, and let's see what those things are doing for us. So I'm going to go to that. And so here's S1. Has another string, right? If I expand on S1, it's not really showing me much more. If I say S1 to uppercase, there you have it. If I say S1 substring 36, there you have it, because let's take a look at S1 again. S1 is ANO, so position 3 would be T, position 4 would be H, position 5 would be E, and then it stops right before the position 6. And if I was to say this whole thing, S1 gave me that. Well, first of all, this is what the whole thing gives me. S1 was a reference to the string. Substring gave me a new string that was only those 3 characters. And then based on that string, to uppercase gave me a whole brand new string. So we got 3 strings happening here. We got the S1, we got the substring, and then we have the to uppercase on the substring. All of those were returning separate strings, not changing the contents of a string, which is immutable. So that's what I wanted to talk about in this video, and in the next we'll start getting into some file I/O.